Well, thanks for joining us here. Today is leap year day, and so we're going to leap into OOUX, object-oriented user experience for agile teams. I started studying OOUX a couple years ago, thanks to Sophia Prater and all the wonderful work she's done to move this space forward. She's the chief evangelist of OOUX and the leader and founder of Rewired UX, as well as OOUX.com. I did a lunch and learn for our integral team a couple months back, and it really resonated with one of our software engineers, and the content sounded familiar. And so he pointed me in the direction of Eric Evans, author of Domain-Driven Design from 2004. And we found some really interesting parallels between Sophia's work now with Eric Evans' book and how he impacted the Agile space starting about 20 years ago. So first things first, these are the experts, and I don't claim to be one, but I do really enjoy the framework, and I like sharing it with other people because it helps me continue to learn. So here's our agenda. We're going to talk about what OOUX is, how it's done, and then we're going to look at domain-driven design a bit and ubiquitous language and see some parallels there. And then we'll talk about an idea of ubiquitous visual language, which is combining the two. And we'll do some examples and hopefully leave some time for discussion. So to get started, we're going to leap into OOUX. And much like this Arctic fox, we are going to break the ice or the snow as we do. So Seth's going to drop a link into the chat. And we're going to head on into FigJam. And for the icebreaker exercise, I'm going to ask everybody, we're going to set the timer for 1 minute. And I'm going to have folks grab a sticky and maybe grab a cluster of them for you, because I'm going to have you do something else with them after the minute's up. But when you hear the word kitchen, what words come to mind? And just do one word or compound word per sticky, and keep your cluster kind of together. And then after 1 minute, we'll take a look at them. And I'm going to set us up with some synthwave. As we work. All right. Now that a minute's up, you grab your stickies and change the color of the sticky to blue for any noun that you have identified. If you've identified a verb, change that one to green. And if it's something else, you can leave it be. And I will give us 30 seconds to do that, along with some lo-fi hip hop. Let's go. All right. Did everyone hear the music, by the way? Oh, can't hear music. Oops. Well, it's it's really nice when you can. So yeah, as we can see here, the majority of these are blue, which brings us to our next slide. Object-oriented UX is a philosophy that relies on the science behind the fact that people think in terms of objects. It's how our brains are wired, in fact. Thought, communication, understanding, and perception are all object-oriented. We think about a newborn, the first words that they learn to speak are certainly nouns. Jennifer Groh, professor of neuropsychology at Duke University, postulates in her book, Making Space, that 9/10 of brain power is spent figuring out what and where things are. And she goes on to say that perhaps the brain's systems for thinking about space are also the brain's systems for simply thinking. And a quick test of this is to try to finding something without referring to other things. So the Arctic fox, for an example, it's an animal, right? Oh, I've already done it. I've already referred to another noun when trying to identify the first one. What else is OOUX? It's a floodlight. So much like a dark room, if you are trying to explore it with a flashlight, you have to smack a couple times. You're not going to really understand everything as you look at them individually with respect to the other things in the room. So OOUX offers that floodlight light switch to see everything in the room all at once. And it is a complexity smasher. A system's complexity comes from how many objects are in the system and how they all relate to one another. So if there's a framework to map those relationships very clearly, all stakeholders will benefit from that exercise and those artifacts. OOUX is also an opportunity, a little public service announcement to product designers. There's a great article out there, The State of UX in 2024. Highly recommend it. It's uxdesign.cc, but in it, they talk about artificial intelligence, automation, and all these technological advancements that are sort of encroaching on what could be described as the grunt work of product design, the componentry, the design system side of things. And so become more valuable and impactful and stay hireable by preparing yourself to face the complexity of systems as early as possible in your process. Your users will thank you, your employers will thank you, and it'll allow you to bring the user centricity that we all focus on in our day-to-day of the product design, to bring it up to the system level. And that's really what OOUX is all about. How does it compare to traditional UX? It supplements it, it empowers it. Traditionally, UX design starts with user flows, features, stories, and most product teams break down the complexity by first looking at those actions, rather than thinking about the objects being acted upon or that you can do things with. A better approach is to map out those objects first, get the nouns right, and then focus on the task flows and traditional interaction design. So in a nutshell, OUX defines a system of objects before jumping into the task flows in IDX. It ensures, most importantly, that your software aligns to the real-world mental model of concrete, defined objects, allowing this digital abstraction world to be as naturally intuitive as the one we walk around in physically. And what's more, developers have been thinking in objects for decades, and as a designer, developer is one of my most important and longest withstanding personas to consider. And a quick note on object-oriented programming. I know that this is sort of a controversial issue with engineers. At a previous role, I brought up OOUX, and one of the engineers flagged it and said, hey, a lot of us don't like object-oriented programming. So shout out to Tom Dayton at IBM for clarifying that in this sense, it really doesn't have anything to do with whether object-oriented programming is used to build an application. Instead, again, it refers to the interface as being perceived by the user as being aligned to the domain objects rather than to any software paradigm. And so just some talking points around why OOUX is amazing. It's user-centered. When we map the mental model to concrete objects, we land on an intuitive product that meets user needs more naturally. When we understand the relationships between the objects in our user's head, then we can offer wayfinding through nested objects. Like if I'm looking at this one, it has relationships with these other two things in my mind. The digital product should afford that navigation from that first object. It's low risk. You know, we at Integral, we like to de-risk assumptions and move with as minimal risk as possible. I find that OOUX, as Sophia says, it uncovers questions from the future early on. When you're talking about what are the objects, how do they relate, what things do we want to be able to do with them or offer to our users, and what are the attributes, what is the structure associated with each object. You know, you really can avoid nasty surprises late in the game when you map this stuff out early. There's really few things worse in product design than a really pretty final comp or even a prototype that gets flagged by engineering sort of late in the process with, you know, concerns around API and just whether or not something's even possible in the given sprint or maybe in the given quarter. OUX is scalable, and it becomes more important as the scale of the system increases. As there are more and more objects, there are more relationships among them, and it becomes mission critical to have a game plan for mapping those things out and hammering them into clarity. Avoiding rework is major. So ask those good questions early and get stakeholders involved throughout the process. I love OUX because it can let, I guess, designers are sort of non-technical compared to developers, but it allows product folks like PMs and product designers and users to impact the technical side of the application that's being built by this Orca game that I'll talk about soon. And sometimes folks will push back and say that, you know, we've got enough process and adding more to the stack is going to slow things down, but it's all about avoiding rework. So slow down to speed up and build the foundation in a way that users will continually and forever thank you for. It's serendipitous. And so when we create these hierarchical relationships between instances of objects that just make sense to users as they consume them, that's where we find delight and joy in these experiences that are designed seemingly the way users would have designed them themselves. So I mentioned Orca. This is Sophia Prater's process to engage OOUX. It stands for Objects, Relationships, Calls to Action, and Attributes. It's a game of 4 rounds. I think there's 15 or 16 steps. And you can do it in an Orca sprint. You can also just kind of use it as a sort of a grab bag and just leverage these tools when it makes sense to do so in your current timeline. But it starts with discovery, so mapping out all the possibilities of what the objects are, what they should be, their relationships, what could be done with them, and then getting into requirements. What are the hard requirements for attributes? Name, description, photo, price, like what are the things we really want to start with in the attributes for an object, and then prioritize them. We do want to add you know, user reviews or some sort of rating, but we're going to do that in Q4, right? So prioritizing the go-to work as you move through the system. And I want to take note here, round 4 is where representation actually starts. So this is interaction design. This is wireframing and prototyping and sketching. And so you look at this process and, you know, a non-designer can absolutely engage discovery through prioritization. They could even do some sketching, why not? But I call that out because it is for Agile teams to sort of all work together upon and to build that understanding before creating those features and stories. And so what are objects? They are the anchors of understanding in an application. They're the real world things that have value to the user or to the business model. They make up the process model within the problem domain. So an example that we'll talk about a bit is like a music app, Spotify or Apple Music. The objects in that stack are songs, albums, users, or excuse me, artists, maybe playlists, the things I'm going to the application to find or listen to or download or whatever those actions are. Objects are typically people, places, things, and content types. And whenever you're unclear about whether something should be an object in the system or not, Sophia Prater has the SIP test. So does it have structure? Does it have attributes, right? So are there data points in its table that are tied only to that entity? Are there instances of it? If there's just one instance of an object candidate in your system, it's probably not an object. But if there are many instances, many songs, for example, that's definitely an object. And it doesn't have a purpose to the user. Why is it valuable in the first place? So some examples of objects on Spotify, we've listed a few. They eventually added playlists, podcasts, audiobooks, live events. Airbnb, there are places, experiences, hosts and guests. They can rate one another. Those are certainly objects in the domain. And then once you have an experience or you go on a trip, you can kind of look back in time at those trips. And then I love all trails. People are looking for trails to hike, maybe points of interest along those trails and in national parks. And then the reviews are very valuable as well. In those same apps, things that are not objects, genres in Spotify, song lyrics, artist descriptions. So these two, they're core content that are tied to an instance of an object, right? And so we look at these pink ones. These are metadata, whereas the yellow ones are core content. Metadata are these sortable, filterable data points that help us sift through instances of objects to find the ones that we're looking for. Whereas core content are typically unique identifiers for the object instance. So like song lyrics, artist descriptions, those are tied directly to the instance. And so let's take a quick glance at Orca discovery. It starts with noun foraging. So OOUX is really powerful when you're just getting started on an app. And it's also useful as you're starting to, or in medias res, like in the middle of an app, to maybe identify objects that are missing from the system or what have you. But noun foraging is a way to do that. You are taking troves of documents and basically highlighting your nouns and looking for the ones that appear the most often, the ones that seem to have the most value based on the context of what you're reading. Rick Williams from GDS London, he's another thought leader in this space. He's identified a strategy to leverage machine learning to do some noun foraging for you. So I look forward to learning more about that, especially with walls of text. That's something machines are good at. But the idea is to take those nouns, identify some candidates for your objects, and then as you move further through the process, you want to eliminate objects and relegate them so that you have a core set of MVP distilled lists to start with. From there, we'll go into a system model, and we're going to show you all of this stuff as we move through the slides. But system model, you start to identify the cardinality, which is the relationship of these things to one another. The nested object matrix takes that work and just moves it a little bit further and gets more precise. And then you start talking about calls to action, who can do what to these objects we've identified, and then you map them all out. We'll keep moving here. So you want to start with a system model. When you're diving into a new domain, you don't want to just start wireframing. It might be tempting to start designing, but if you really want to uncover some knowledge that you can then share with the team, you start with a system model. So looking at a music system model, I've just pulled 4 of those objects from the Spotify list, and you start to just connect them. And each time you connect something in one direction, you're saying one instance of this object has this relationship with this other type of object. So an artist in order to be on this app, they have to have at least one song, right? And then a song may feature one to many artists. There's got to be one artist, and there might be another feature listed in the title. A playlist has 0 to many songs. So technically on Spotify, you can create a playlist and give it a name, but before you add anything to it, it still exists. So technically it can have 0. It's not a very interesting playlist, but it's technically true. Albums have many songs. I've yet to find an album that has just one song. So has many is a rare qualifier here, but it's accurate in this case. It's usually 0 to 1, 1 to many, 0 to many. But in this case, has many is accurate. The song is added if it's a pretty uninteresting song, and maybe it won't ever make it to anyone's playlist, but it certainly could. So 0 to many. And so you see, you start to identify what these relationships are. And then once you're feeling pretty good about your system model, take it a step further. You bring those same objects you started with and list them across the top. These are your host objects. And so it's helpful to think when I'm looking at this one, for example, I'm thinking about one artist, right? So Leon Bridges. What relationship is there between Leon Bridges and some other artist? There's 0 to many similar artists, 0 to many other artists that they are a part of. Like, so think like Method Man. He's also a part of Wu-Tang. So maybe there's some value in connecting a Wu-Tang profile link to Method Man's artist page, for example. And so you go box by box and you really pressure test, what the mental model is, or maybe what you want to make it. So I used Spotify as my inspiration here and went through the app and really mapped out everything. And I learned that you can actually add a playlist to another playlist. You can add albums and songs to playlists, but you can't just add an artist to a playlist. And so when you do this stuff, you're not always looking at some app to figure out how it works. You're thinking about how you want your app to work that you're building. But yeah, the nested object matrix is an extremely valuable exercise, very collaborative. You can have conversations about this stuff all day. But one area where Sophia says a lot of students of OOUX, they tend to shy away from is this host object nested in itself, right? So song, album. You really want to lean in on these. So if you're looking at an Amazon product, for example, scroll down a bit, customers also bought these other products. So that's an instance and then suggested instances of the same object. So you really want to lean in there. There tends to be value to unlock for users in a lot of applications. Next step is the CTA matrix. So you're listing your objects on the left, and bonus points if you actually do this matrix and put your roles across the top. Different user types are going to have different action affordances for the objects in the domain. And so, listener, this is stuff that we're familiar with, but there's probably a publisher user role for Spotify, like for the actual artists. When it comes to other artists and other songs, they probably just listen to Spotify on their own sometimes, just as a listener would. So they probably have those permissions, but they can also publish and maybe unpublish a song. Sometimes an album gets promoted and maybe a publisher has some action affordance to pay for that or to start that process. And so you see how the CTA matrix can rapidly get a lot of stuff on the board at once. You bring in your PMs, you bring in your subject matter experts, and you talk about what you want these to be. And as you move through Orca, you prioritize what's going to come first, what's going to come later. Maybe you start with just being able to play a song and download it. In Q2, you move into some sort of social structure where you can kind of rank them across the system. And then somewhere down the road, you have playlists, perhaps. The next step is the object map. So the important relationships that we identified in the matrix, the nested object matrix, we want to bring them into a map and also now bring in attributes. So what attributes do we want to list or have associated with each of these object types? So again, with Spotify, we've got song titles, maybe a looping video if you actually go to the now playing page. We've got lyrics, credits, etc. Genre I put here, but I think maybe this is hidden. When I go to, let's say, Kodak Black's artist page, for example, it doesn't tell me that he's a rapper, right? It doesn't tell me that I'm on a hip hop artist page because as a fan, I maybe already know that. But I listed it here because, certainly there is some relationship table in the system that's tied him to one to many of these genres. Yeah, so we kind of get the idea. We list out our core content. We list out our metadata for all of these object types, but this isn't where it ends. What's next is to rank them in terms of priority. So what's the most important to the user? And you sort of stack rank them. And then from there, you finally go into wireframes. And maybe you keep them color coordinated like this, and you start to place all of these pieces and boxes on a viewport sketch. And now you're well on your way to traditional UX. And I've been talking a lot. So with that, I'm going to pass the mic over to Seth. He's a software engineer here at Integral, and he's the one who spoke up during the lunch and learn and said, "Hey, I've heard this stuff before." So with that, I'll let Seth take it away.
Thank you, Danny. So yeah, I kind of wanted to bring in the perspective of software engineers into this discussion about object-oriented UX. Because if you are a software engineer, you might have noticed that what Danny is describing sounds like really familiar. And when I heard it, I immediately thought, hey, Danny is describing a practice that I thought was an XP practice. I was wrong about that. That's called ubiquitous language. Ubiquitous languages actually comes from the book Domain-Driven Design, which I have and I use as a reference occasionally. It's a great book. I definitely recommend everybody taking a look at it. And it's kind of like a practice that involves the whole team. And the idea is that everybody on the product team, including the designers, including the product manager, including the developers, should have a shared language when they're talking about the application and when they're talking about the domain that application operates in. So in the Spotify example, that means that everybody on the team knows what a song is specifically to Spotify. So they know that songs can be added to playlists. They know what a playlist means as well. And they know that playlists can or can't be added to other playlists. They know the domain. They know these business rules. And product designers and product managers and engineers can talk with each other, as well as subject matter experts. If you're in a really complicated domain, and if you have subject matter experts, you can talk to each other and be using that shared language. And I wanted to go through a few tips from the programming side to talk about how to enable this. Because I think it'd be a real shame if your designers are doing OOUX, they've already got this language kind of hammered out. It'd be a real shame if the programmers and also the product team, if the rest of the team didn't utilize this opportunity that they have in front of them. So from the programmer perspective, well, what can we do to enable this shared language? I think the first and most important thing is that the code that the programmers write needs to be written in the shared language. So it should read as close to English sentences as you can get it. And those sentences should be referring to things that are in the domain model, things that are in your ubiquitous language. And when you type out in the Spotify instance, again, when you type out song in a function name, you should be referring to the same idea that the designers and that the product manager are going to be thinking about. There's a few things you'll have to do to get that to work. So let's go to the next slide and talk about that. First, you're going to want to make your language visible. So everybody on the team needs to be able to refer to some kind of diagram, some kind of documentation. It needs to be readily available to be able to, while you're having this conversation, maybe scratch your head and look at the wall and say, oh, that's what I'm trying to think of. I'm trying to think of a playlist, right? And so this documentation needs to be really available. And documentation, it's only as good as however many people are reading it. So if people aren't using it, if people aren't reading it, it's either not in the right spot or it's not written well enough. That's a problem that would need to be addressed. I think the wall, if you're in an office, the wall would be a really good place to put this, or maybe a whiteboard that's by your team's, area, because everybody can see it all the time. Let's go to the next slide. The other thing you're going to need to do in order to enable this, or I guess you don't have to do this, but it's going to help drastically, is to separate your technical details and your domain logic in the code base. So I have a screenshot of one example of an architecture you could adopt to do this. There's multiple architectures that follow the same idea. And really, this sort of an architecture is core to the whole domain-driven design book. He talks about this a lot. And the idea here is if you're doing, let's say you're trying to add a song to a playlist, that's not a database operation, right? That's a domain operation, adding a song to a playlist. The technical detail of how that is technically carried out and portrayed to the user probably involves putting a row in a database somewhere, and then showing some HTML to the user, right? Those are the technical details, but the core, in the domain, you're adding a song to a playlist. And so you want to have those two things separated. And in the clean architecture, the way you would do that is you would define your domain objects as entities. Your entities aren't allowed to depend on anything else in your code base. They're kind of solo. It's just like pure, if you're doing it in TypeScript, it's just like pure TypeScript, right? And the use cases could be interactions between those entities, and then all the details about displaying those things on the web or on a mobile app, or storing those things in a database. All of that happens at the outside edges of your application. And those are the things that depend on the core domain. And that having those kinds of dependencies or having that dependency flow, I guess, will really make it easier for the team to code in the language of the domain. This isn't particularly easy to do, though, and you have to be really careful with your code. I also want to make a note here about object-oriented programming. It doesn't have to be an object-oriented code base to do this. This architecture here, if you're using hexagonal architecture as well, I believe, I'm not sure about others, but you could do these not in an object-oriented way. You could do functional programming and still follow this architecture. As long as your language has a way to define, you might need types. As long as you have some way to define just any domain object, you can do this in any language, in any programming style. For instance, in a functional style, your interactions between the two domain objects would just be functions, right? And whereas in an object-oriented style, you might have two classes that are calling methods on each other. But you can do it either way. It doesn't have to be in an OOP setting. Let's go to the next slide. So a few more things. When you're writing it, in order to really enable this shared language in the whole team, when you're writing the code that has to do with the domain logic, don't put any technical jargon in your code, or minimize the technical jargon, right? So the code to add a song to a playlist probably shouldn't mention a SQL query, right? That's a technical jargon. Or probably shouldn't mention that the song is represented as XML, right? All of that's technical detail that should be on the edge of the system. And another thing to do is to use test cases. if you have test cases against that core domain logic in your system, they should be written in, like I said, nearly English, and your product manager, even your designers, or maybe like a user tester could be able to come in, read the test cases, and understand how the different objects fit together, even if they don't totally understand the code base. That's the goal. I realize it's idealistic, right? Like you probably won't be able to perfectly hit that goal, but if you keep it as a goal, you'll get closer than you would otherwise. And there's this quote from Eric Evans that it takes fastidiousness to write code that doesn't just do the right thing, but says the right thing. And that's the goal here. You want your domain logic to be so clear that you want it to say the right thing so that people in your team can understand it as well.
Thanks for that, Seth. Yeah, as we were looking at Eric's work and Sophia's, I realized that they're really identifying the same target from different disciplinary perspectives and about 10 to 15 years apart. But if you consider Eric on the development side and Sophia's work getting things all the way to interaction design on that same solid foundation, we're talking about a ubiquity that goes from the very beginning of discovery to all the way to production. In the same way that OOUX encourages us to always have an object look like itself, and that different objects should look different, there's the potential to land on a ubiquitous visual language that has the language that developers use in its name. It has a consistent visual language that aligns with the user's mental model. And I think that is sort of a product utopia that lean teams can aim for. And that was a cool, I guess, thing to stumble upon, that there's a few years and a discipline difference between these two thought leaders, but they're really talking about the same thing, and that's alignment. So I wanted to share an example of OOUX in the real world and somewhere where I found it useful and experience. I was working on a supply chain product, and we had this concept of a reorder quantity to help what we called shippers deal with low inventory. And it seems like a great feature, right? Like, we couldn't understand why shippers weren't using it. When your total inventory across all your warehouses goes below a certain threshold that the shipper defines, the shipper will be alerted to create a purchase order and bring in some more units. But no one was using it. And so we needed to validate our understanding of the mental model. In reality, to make the feature valuable, the inventory alert would have to live in a different table, right? It was part of a different object in the shipper's mental model. And what would make it useful is to be tied to individual warehouses. So when inventory at the Detroit warehouse goes below a certain threshold, alert the business to create a purchase order. Unfortunately, the data point for reorder quantity was tied to the product itself, that object. So let's think, for example, about the Swamp Cooler 3000. I'm a former Florida man, so swamp coolers are very important in that great state. But if you think about a distributed supply chain where you have multiple warehouses that are ideally fulfilling orders in local demand clusters, you would probably have a lower threshold for a Detroit warehouse for an AC unit than you would in Miami, for example. It's a lot hotter. Air conditioning is more in demand there. So a network-wide threshold was not as actionable or telling to the shipper as originally conceived. And so what I realized, and I was studying OOUX, just kind of getting into it as we tackled this problem, there's something called a junction object. So you've got a product, it has its own photos, description, all that stuff, the swamp cooler. Then you've got a warehouse, which is another object in the system. It's got a city and state, it's got an address, it's got hours of operation. And when those two things come together, that is a junction object that has its own table of data points. And reorder quantity becomes valuable when it lives inside the junction object and not until then. And so when we talked earlier about reducing rework and really mapping out the mental model, it would have made sense to slow down a bit when doing that early discovery around inventory and how shippers actually think about it. What's in their mind when they think about managing those things and where they're managed. And so that's a pretty heavy lift to build later, right? So the cost of change is a lot greater further down the road. So I've got a bunch of resources here that I found super helpful in my venture into OOUX. There'll be a copy of the slides sent out, so feel free to dive into that stuff and learn and share the learnings to learn even faster.